Hi everyone, Actuary Dude here. So now we're going to check out another question. It's relatively simple, and yeah, just thanks for all the comments and the likes and the views. Really appreciate it. So just to start with, an individual makes an investment of £4 million per annum in the first year, £6 million per annum in the second year, and £8 million per annum in the third year. The investments are made continuously, so that's going to make a difference throughout each year. Calculate the accumulated value of the investments at the end of the third year at a rate of interest of 4% per annum effective. So that means if we have an interest rate of 4%, then we know that our continuous interest rate, delta, is going to be the log of 1 plus our interest rate, which we can use Excel to find out what that is, because we know that e to the delta equals 1 plus I. Okay, and moving on further, so now let's find out the accumulated value. Now when we're trying to find out the accumulated value, we're going to be using series, but let's just have a quick look with my great artistic skills on what these payments actually look like. So we're starting here and we're getting £4 million in the first year. That's pretty good. Then in the second year we're getting that 4 million again plus another 2 million. So I'm going to write it like that rather than writing it as a 6, and you'll see why. And then in the next year, we don't need that bit there, we're getting, in the third year, we're getting 8 million. So we're getting that 4 again, we're getting that 2 again, and we're getting another 2, which is excellent. And we just want to find out what is all of this going to equal. So to find that out, let's see, we're going to take 4 million in the first year. It's a series, we're getting that, 4 million each year over 3 years. What's that going to be equal to? Then we're going to be getting 2 million as a series over 2 years, and then we're also going to be getting 2 million as a series over 1 year, which is equal to 2 million anyway. And whatever that equals will be our answer. So how do we find this? Well, finding a series, I mean, you can check out a lot of the other videos, but it's essentially 1 minus v to the n over I, but instead of using over I, we're going to be putting it over delta. So in fact, I didn't really show that. That should be a line over there because it's a continuous series like that. You could do this another way by using integrals and so on, but that way we're putting delta n over like that. So this is what we're dealing with over here. And yeah, it's fairly straightforward. Let's have a look at Excel to see what the answer is going to become. So I've kind of already mapped this out a little bit, not in the best way, but just looking at it, we can see that if we put down what the interest rate is, the effective annual rate, which is 4%, then I've already calculated here that delta is the natural log of 1 plus the interest rate. So, sorry, I'm not sure why that's just done that. So that's that. Then I've also found V, which is 1 divided by 1.04, which is, I guess what V is. We use the ordinary annual effective rate. And here we're saying we're getting 4 million in over 3 years. So that's the cash flow. C, that's in years. We're getting 2 million over 2 years, and we're getting 2 million over 1 year. And then I've worked out an annuity over here. So I've said 1 minus V, which is B3, here to the power of n, which is that, divided by B2, which is delta. And then I found it for the next bit and the next bit, and as you can see, only n changes there. Now what I need to do is I need to take that amount, multiply it by the cash flow amount, so we're getting times 4. So that's this over here, so we've got the annuity times 4, and now to turn this into a series, we have to compound it again, which is 1 plus the effective annual interest rate to the power of however many years we're using, which is that. And if I just lock in that interest rate there, then I should be able to just drag this down and see what I get to. There we go. $18.94 million. So million pounds. £18.94 million is what we're getting at the end of the third year. So thank you very much for watching, and have an excellent day.